Thanks everybody again for having me. I'm going to talk today about secondary use of multimodal data for research also, and then clinical decision support. So just to go over kind of what I'll be touching on today. So I'm going to give you a little bit of background about Geisinger for those that aren't familiar. Talk about EHR adoption and secondary use. So talking about the both the policies and procedures in place, legislation that actually mandate the use of EHRs, and then how we can then use that effectively within those regulations, and really laying the groundwork for more collaboration between sites. I'm going to talk specifically about our data infrastructure, architecture, and standards. Then I'm going to talk about kind of the multimodal data within that warehouse, that data lake. And then I'm going to talk about the types of folks that are needed to support such an effort. Tools that users can use on top of that, and then talk about our collaborations, give some examples of what you can use and what you can do with this data, specifically our MyCode Community Health Initiative, and then which is our biobank, and then lessons that we've learned and directions that we're headed. So Geisinger itself, I just mentioned we had our 100-year anniversary in 2015. So we were established in 1915 by Abigail Geisinger. So she had a vision that she wanted to make a hospital in rural Pennsylvania and make it the best. So she actually had gone to Mayo Clinic and got one of their lead surgeons, Harold Foss, and so he was the first CMO of Geisinger and CEO. And a little bit about Geisinger Fast Facts. So we serve more than about 3 million residents in 45 counties, from South Central to Northeastern Pennsylvania. And then we also have a more recent acquisition in Southern New Jersey. We have approximately 30,000 employees and about 1,600 physicians. We have about 12 hospitals and 2 research centers in our organization. Our health plan also is attached to us, and we have over 550 members annually throughout Pennsylvania. And then we also have affiliates in other states such as Delaware and Maine. And this is a really hard to read map, but it kind of shows Pennsylvania, and all the dots would be different locations of our facilities. And then you can see down in Southeast New Jersey where our more recent acquisition is with AtlantiCare. So again, taking a step back, and let's talk about just electronic health records in general. So there's 2 main things that I want to touch on that I think drive the adoption as well as the use. So HITECH, so the Health Information Technology for Economic and Clinical Health, created the Office of the National Coordinator for Health Information Technology. And then HITECH and ONC continue to create incentive programs known as meaningful use. So within those 2 aspects, we have a regulation that mandates the use of electronic health records, and then we have measures to then use quality on top of that for meaningful use to be paid for the use of electronic health records. So you'll see that over time, since 2007, 2008, we've basically doubled the amount of hospital systems that have an electronic health record and use it on a regular basis. And then so we have this massive influx of EHRs coming online, but what about the quality of those electronic health records? So are we just doing the bare minimum to have an electronic standard, or are we actually doing something that's meaningful on top of it? So the clinical quality measures were created to help measure and track the quality of research, as well as, or the quality of the data, as well as not just implementing the electronic health systems. So during this time, various stages have been implemented, and they aim to increase the quality and interoperability. So can we share the data, and are the data that we are sharing actually useful to those that are receiving the data? Again, this is very much centered around care, but also based on incentives. So as of 2016, over 95% of hospitals eligible for Medicare or Medicaid incentive programs have achieved meaningful use at some level. So there's multiple levels that have been issued throughout meaningful use that have different types of measures and different types of incentive programs tied to them. So we have the ONC, we have the mandate for actually using electronic health records. There's also additional scores that we can look at to assess quality within those. So ONC is one way, but then there's more private or open source. So the Continued Quality Improvement Program, again, is something that is used to be able to enhance, and it's addition to just ONC certification. HIMSS has a model or a score, risk electronic medical record adoption model, and it basically will show robust areas of implementation within your electronic medical record. So again, that's a marker for how advanced you are in your implementation. And then as well as the HIMSS value score, which is another kind of open source focused on the benchmarking and those types of things within the data. So we have a lot of things talking about specific EHR elements, but not really full blown across all of the medical record. So we have regulation, we have incentive programs tied to it, and even with those certain quality measures, not all of these implementations are equal. So when we think about electronic medical records, we need to think about 3 to 4 key elements. So incompleteness, inconsistency, and accuracy. In the world of big data and data in general, electronic medical record data is completely different than what we're used to. So there are a lot of missing data elements due to ascertainment bias. So patients present on irregular intervals, they can move between healthcare providers. If we don't understand that this is happening and actually account for it in our analyses, a patient's journey can look very different compared to someone else's when they in fact have the same journey. Inconsistency, so this is where data can be collected and recorded differently within the electronic health record. And so this can vary by location or provider practice. So within our health system, we have hundreds of outpatient ambulatory care centers. We have multiple specialties, and within those specialties by region or by provider, they can have different workflows which result with data being captured and stored differently within an electronic medical record. So for example, you could have one doctor who simply puts it in a clinical note, another one uses structured notes, another one actually has gone through and created some kind of special diagnosis code or smart data element. All of these three things are the exact same care process. It's the exact same information on that patient and the care that's provided, but it's stored differently in a database. So this is something we need to consider and understand when we're actually doing downstream secondary use of data, is how can we accurately coalesce all of these things together and unify at the concept level to understand that care process. And then lastly, the inaccuracy bias. So varying levels of specificity, standards, and precision can exist in the care process, which can cause inexact or incorrect information. So now that we understand that there are a lot of folks that use EHRs, there's great reason that we should be working and collaborating together. We need to understand what pitfalls are available within that data through the inconsistencies and et cetera. Now, how can we actually use it? So the regulations that exist focus on EHR adoption and interoperability for treatment and payment, which is a very important distinction. It doesn't include research, which is separate. That is actually governed separately, which I'm sure all of you are familiar with, but covering my bases here. These regulations and governing bodies provide minimal to no guidance on data quality, data governance, or secondary use. So all of the things that I talked about previously are solely for treatment and payment, interoperability, not for secondary use for research purposes. The regulations that allow us to then use this data fall under HIPAA, the common rule, and then HITECH for sharing the data globally. So as a framework we have data, we know how to have the regulations to use it. I want to talk about our experience at Geisinger from a data warehousing, secondary use experience. So really talking about the infrastructure as well as the users and the support staff involved. So I'd say 4 years ago now, we started talking about an increase in business need for data. So we've had a data warehouse since 2007. We had multiple iterations of what that actually looked like. And then we had a strategic vision to create a new data warehouse and data infrastructure, unifying as much as we can a few years ago. And in doing so, we really looked at a few core values. So organizational commitment, business needs for both operations and data scientists, which can be very different, data architecture and operations, support, So if you have the data that exists, you actually need folks that can help you access that data and understand that data. So through phenotyping, subject matter experts, et cetera. And then standardization anywhere that we can, hardware, software, methods, specifically methods is an important one as well. So at the end of the day, these are the things that we continually think about when we had developed our environment and then used the environment, which will be the basis for a lot of the lessons that we learned through this process over the last few years. Our original data infrastructure prior to us, the clinical decision information system, was a Teradata production environment. It had about 13 terabytes of storage, which would be about 30 terabytes compressed due to redundancy, and we had roughly 15 data sources. Now, that's largely our EHR, our billing systems, and our claim systems, which is a big chunk of what we're going to make decisions on. But again, it was only 15. It required a lot of manual ETL development, a lot of work to just maintain that. What we had switched to, based on the need of, we need more than 15 data sources in our infrastructure. We now have over 100 data sources. We switched to a Hadoop production cluster. We're currently on 2.6, moving to version 3 very shortly. That is a 60-node cluster with 2.5 petabytes of storage and 30 terabytes of RAM. So you can see that we went from 30 terabytes of uncompressed storage to 30 terabytes of RAM in the new system. So it's a very significant change in what we were actually trying to accomplish. And again, the organizational commitment for this to develop this centralized resource was paramount in this. So it's not an easy investment to switch that drastically from one environment to the other. And it was, again, based on owning and growing this resource for multiple decision supports and as well as research. So we created this data lake with a central hardware infrastructure that allows users to be able to access it across the organization. We also centralized our support teams where we had over, I think we went from 200 or so analysts that were split out in a business intelligence role across the organization, and then consolidated that into a single core into about 120 or so analysts that serve all the needs of both the operations and the research world. Those support teams develop and maintain the platform. They do ETL, and they understand the information security and governing access. So they're very much on the just kind of operational side of what there is in our data warehouse and our data lake, not so much in the downstream understanding of the analysis. So we do separate those out as different functions amongst our organization. And when we talk about the different data sources, again, in our old world, we had EHR data, we had insurance claims, we had billing. But when we transitioned into the data lake environment in a Hadoop, we added many, many more data sources. And the focus of adding these data sources was based on discrete data that is captured at the point of care in systems that have an interface back to Epic or an EHR, but they don't provide all of the information back to the EHR that was originally in the system that created the measurement. So something like pulmonary function is a good example, where we have a vendor called BreeSuite. We have specific measurements that come across an interface into Epic, but it's only a subset of everything that's measured. So if I would go look in the EHR, I would see 1 to 2 measurements in the result record, and sometimes it's discrete and sometimes it's not discrete. In this case, over time, it actually changes. But if I go back to the source system, I probably have 50 to 60 different measurements within that system itself. So our focus with the new environment was, we understand what we can get out of our electronic health record. We want to then add all of these rich resources where we're having measurements and we're creating decisions on those measurements, but we actually don't know all of the measurements that went into that decision making. So that was one of the big business needs as to why we went from 15 to 100 data sources. So things like pulmonary function, through BreeSuite got added. Tumor registry would be all of our diagnostic cases. So this follows many different standards over time, SEER, Ford's, et cetera. So this would be anything that's treated or diagnosed at one of our facilities back to 1943. And then we focused again on the very discrete and useful information that is in these additional data sources. So in cardiology, we have a wide spectrum of information. Accelera is our CT and MRs, and again, it's structured, so it'll have information about findings and measurements based on the actual machines. The Muse is our electronic, our ECGs, so that was going back to 1980s. So this would have measurements off of the different leads, and we use this heavily right now for predictive modeling. Our Echo database goes back to 1991, and again, this is discrete findings and discrete measurements based on the machines themselves. And then we also, similar to the tumor registry, we have different registries that exist for accreditation purposes. So Apollo is a Geisinger made-up name, but basically what it is a collection of data that is based on the American College of Cardiology, the Society of Thoracic Surgeons, and various other organizations that for accreditation in our residencies and fellowship programs, we actually have to maintain these registries, which has very useful data because it has things like outcomes in addition to just different measurements. So these are things that we also bring into our database as well. Radiology, we have that information back to 1997. Not as discrete information here. It's much more useful to look at the questions that are asked by radiation rad techs. So they will ask a lot of information that's useful that does not make it into the electronic medical record. So it'll be things like personal history during a mammogram, family history, things like that, that may not necessarily be as rich in an electronic health record, but very important for a radiologist to know that in the context of reading. So these are things that we bring in as well. DEXA, similarly, T-scores, E-scores, bone densities, things like that that we have specific measurements on. Pathology, similarly, it's again, questions very specific to the actual specimens and the types of specimens. Provation, very similar, that has upper and lower and GI scoping. DAT-STAT is our patient-reported data. That would be things that we serve up to patients through our portals, as well as in clinic, so they can actually get information very rich that's patient-reported. And then sleep studies, we have a host of different technology that we've unified over time. So Alice, Sandman, Sleepwear, Harmony, et cetera, goes back to 2005. So all of that data is very important and we need it. But as I said, in addition to just workflow standards or differences in workflow that can cause data to be captured differently, there's also terminologies that are different. So in local terms, we need to make sure that we're unifying these things to national and international standards. So things like LOINC, RX norm, HL7, CDC Rex, NOMED, UMLS, we need to take the data from all of these systems across the organization and unify them into standard terminologies. Why this is important isn't necessarily for Geisinger physicians. I mean, it does make it easier, or researchers. It's very important for if we want to work with another healthcare organization or work with another research organization to be able to speak the same language across different entities. We use existing methods and standards where we exist. So things like the Value Set Authority Center from the National Library of Medicine, FinVads, which is the CDC's version of that, eMERGE, et cetera. We don't like to remake anything that exists. Anywhere where we can follow a standard that's already in place for doing work that we're doing and make it reproducible and make it shareable is something that we try to embrace. And then one thing that we do is our data lake, which has all those 100 sources, is a massive amount of data. That will all it's replicated data. It's not modeled data. So focusing on how we can use all of that data, conceptually align it, mark it up to the standard nomenclature, and then model it for research use is very important. So we have 100 data sources, we use about 30 of those. And within those 30s, we don't use every single table. So you can't use everything all at once. We know that it's going to be a slow build to be able to align all these things. And then that's where we focus on a core set of data and expand upon it over time to be able to add to that as research projects come up. And to that point, we develop ETL scripts to and from additional data models. So we bring data into our staging area. We have our own user-friendly data model for our analysts. But then to be able to collaborate, we have additional data models, which I'll discuss the various different models. So what we need to maintain then is a library of transformations that occur to and from those different databases. So we're only maintaining a single data model and not 10 different data models or 4 different data models. So those common data models that we participate in, there's 4 main ones that are externally facing that are all sourced from our internal common data model, which I'll reference in a second. So the Healthcare Systems Research Network, formerly was the Health Maintenance Organization Research Network, is a large consortium of mostly in payers, but also some providers. And they have the virtual data warehouse. This was a very early distributed data model based in SaaS that users could then share data openly. And they're not actually, the caveat with this is it's distributed, so you're actually sharing code openly. So results get shared, but basically you're sharing code to then be run at each individual site to then put the results all together at the end. Similar to the VDW, PCORNet's common data model is analogous in that it has the same distributed data network with a similar data model. They're almost exactly the same and can do similar results there. The Odyssey, so the Observational Health Data Sciences Informatics common data model is one that most folks are moving towards now. So I think this is the most, even in the pharma space, this gets used quite a bit. There's a lot of momentum behind it. And it's also being used for things like All of Us and additional research studies. And we also maintain, not as regularly, but the informatics and integrating biology in the bedside. So I2B2 is another model that we maintain. This, I think, is slowly being phased out. It's very useful in that you can stick any type of data into it. The downside is that it's much more difficult to get data out of it. So it's, I think the field is moving away from I2B2 and more into Odyssey from what we've noticed. And then again, all of these get created from our common data model. So this is just a homegrown data model where its driving focus is making it easy for analysts to use. So we have 147 tables. Again, I said it's about from 30 different data sources. There's about 2,800 different columns in it on about 2 million patients, which results in about 3.8 billion observations. Our largest tables are our vitals tables, our labs tables. Vitals, we have close to 1 billion rows, and we get about 2.8 million a week. And then labs would be another 535 million, and we get close to 1 million a week. Now, in addition to those, so the data sources that I've been discussing are very much EHR structured data. In addition to that, we have a separate environment, both in imaging and genomics, where we bring in, basically have created a research version of PACS to bring in imaging to help with different studies. So we have de-identified versions as well as identified versions of this environment, and we use DCM4J, which is an open source program, to host this. And it's mostly cardiac and neuro, again, CTs and MRs. And it's really, again, based on the need of the business. In addition to that, we have our genomic environment. So we have whole exome sequencing data. We have about 145,000 whole exome sequences at the moment. And we do variant-specific testing within that environment. Now, that's describing everything to this point has been really about the data, why we're doing this in the first place, and the ability to share. But in addition to that, we have all this data. We need to have a support service in place to actually use it. So we need to focus on governance, architecture, reporting and analytics, data science, image science, research, and then we also have a clinical trials and investigator-initiated clinical research core. So all of these cores sit centrally, similar to the way that we have centralized resources for analytics, to be able to help anytime that anybody comes in with any question. So if it's a researcher If it's a clinician that wants to do a clinical trial, they may not have the resources in their department or their lab to do everything by themselves. So we provide services and centralized cores to help with those types of things. Now, specifically on the data side, which is my team, one of my teams, we've used a data broker model. So again, as I said, data is captured for treatment, payment, and operations. We have a data broker in place that connects researchers to the data itself. So pursuant to whatever their IRB approval is, our data brokers will review those protocols, understand what's being requested, and then deliver that data to the researchers. So excuse me. So the Geisinger Research and Clinic, for any human subject research and data needs, will come to our data team, and they basically serve as subject matter and data quality experts. So our team's focus, again, is on the clinical workflows and being able to take the clinical workflows and understand conceptually how to get that data. In addition to that, they also assist in protocol development and budgets. So anybody that's trying to do research can then come to us. We can help to really understand the whole process of a project from data and help them in their grants. And additionally, that's where funding comes from our team. So we're also a part of everyone's grants that get submitted. We also work closely with our enterprise information management team, which is centrally housed and located. And we really work on the data modeling and data governance side of things. And governance here is more on defining and understanding and using the data, not necessarily on the security side of things. And again, we have many external collaborations and research networks that we participate in, so our team drives and moves those things forward. And most importantly, we maintain validated, standardized phenotypes, and our main focus is on reproducibility and quality. So if a researcher comes to us and says, I have a need for a phenotype, we first look to see, do we have that cataloged? If so, what was the definition? We serve that definition up to them, and then they can view the positive and negative predictive value based on that standardized and validated phenotype. The interesting thing then is, if they have a strong need that they need to change that definition, they have the ability to do so and then can compare the changes to that phenotype to the existing one that was already in the catalog. We have a host of common self-service tools. So in our internal data model that we've developed, we have a de-identified version of that that's made publicly available to, available to researchers within the organization. So they have a data access agreement. They can then go in and access this data through any tool that they prefer. Web intelligence is business objects, Microsoft SQL, Hive SQL, SAS, R, Python, many more. And in addition, the external collaborations that we talked about, so we are part of the Healthcare Systems Research Network. We also, so that we would have the virtual data warehouse for that. We're part of eMERGE phase 2 and 3. And this is the electronic medical records and genomics with a focus on using EHR data to be implemented at the point of care for genomics. We're part of Odyssey, so the Observational Health Data Sciences and Informatics. Again, this is a data model, but it's also a community to be able to work together. PCORI's CDRN, so we're part of the PATH network specifically. And then we have a strong collaboration with the Regeneron Genetics Center, and that collaboration is called Discover. Now I want to talk through, we have the data, we have the teams to support it. I want to talk through some real world examples of how we've used this data. And so specifically about our MyCode Community Health Initiative, Aim High, which is more on the machine learning and radiology space. Another example in radiology is the work list priority. And then lastly, care gaps. So MyCode was started in 2007, and it's a biobank that allows researchers to be connected to participants. Participants sign a broad consent to combine their electronic health record data both retrospectively and prospectively in a de-identified fashion, and we collect biospecimens. So we collect samples at the point of care at your next clinical visit. So we don't bring people in outside of their normal workflow or their normal care flow. It's basically a very hands-off approach. But the consent also includes the ability to recontact participants. So if a study comes up that we would have a very specific phenotype or genotype, those patients can come in for future projects. Those projects would have an individual IRB approval. But if it is data that exists, so it's anything in their EHR or generated from their genomic data, there's no need for a separate IRB approval for those patients. We have that pool of data available. Researchers put their own protocol in, go to the governing board, and are able to get access to the data. And most importantly, the ability to communicate medically actionable results. So we made the decision when we started whole exome sequencing on our participants in 2014 to be able to communicate specific actionable results from the ACMG's list of secondary findings. So that's a mandatory part of participation in our biobank at this point. So this is the overall process, and I'll break it down by consenting, samples, and return of results. So the first piece of it, again, we utilize a in-clinic consenting model. So we've had great success of having that discussion with participants and patients in the care process, making in the waiting rooms and things like that. And so we believe that because it is a difficult subject matter, it's much harder to do this via just a single form or electronically. We want the ability for participants to be able to ask questions and truly understand. Because of the return of results piece of this, it is a very important part of what we believe in the consenting process. But again, we do have the ability for electronic consenting and then specific outreaches. So we can do targeted mailings, targeted calling, if there is a disease area that specific researchers would like to do. And again, this all just shows that everything that comes in through all these different things gets pushed down through into our enterprise data warehouse and then into a specific MyCode database. Once we have individuals' consents, we then place an order into our EHR to be able to collect that blood at the next visit. That gets sent to the clinical lab systems, phlebotomists catch it. That'll get extracted, sent to our central lab. The central labs, it gets picked up and then couriered to our research lab, which is on campus as well. But then there's also ways, this illustrates saliva, but there's ways for attaining a sample out of the normal process. Those go directly from the participant into the biobank. Of note, up until this point, everything is still under CLIA, so it's under our purview. We then send data for sequencing. So that is the upper right here. It is, unfortunately, our sequencing partner currently is not CLIA. So the data that gets generated from that collaboration is not able to be used for research, or sorry, for clinical decision support, but it can be used for research purposes. This data gets uploaded to DNA Nexus. We then access that data, bring subsets of that data down, specifically the variant call files, and then we use that data for two purposes. One is any research study, but then two is we interrogate that data based on the ACMG list of secondary findings, and then we look for specific variants that are potentially pathogenic. We send an orthogonal sample out for for confirmatory testing, and then if that gets confirmed, it generates a clinical report that then gets returned to the patient as well as their primary provider, and then they get referred into genetic counseling for future follow-ups. So the step that I want to then expand upon is what does it mean by interrogating, that sample for a potential secondary finding? Well, we start with our whole exome data. We then have basic filters that we have in place to get from all of the people down to really the 2% that probably are going to have results. So we have multiple variant annotations. VEP, ClinVar, and Nomad are our three primary. So based on different filter levels within those, we then create basically a triage method that is computed at the beginning, but then by the gene level, variant level, and variant quality filters, which create a single list of variants, and those variants will get reviewed by a variant scientist, not at the patient level. So if one patient has, or if 50 patients have one variant, we're only reviewing the variant, not the 50 patients, which is an important distinction. So that reportable variant list would then get sent out for CLIA confirmation. Anything not reportable, we still store in our database. And so what this ends up looking like is, at the top is our Geisinger patient population. The first part of this funnel is we have close to 260,000 that have consented into the study. Again, because we don't require patients to come out of their normal care process, we collect samples on a smaller number than that. So it's about 176,000. We then have about 93,000 currently that we've processed. We'll soon be able to process 145,000, and that number is the same. And then the output is we've returned clinically actionable results to close to 1,500 people out of the 92,000 or 65,000, depending on how you look at it, at the end. So another example of using this data clinically is the AIM-HIGH trial. So this is a trial that gets at understanding, hopefully understanding, risk versus benefit. So we do a lot with our understanding gaps in care and prioritization of resources. Those are the two things that we care deeply about. We have, finite resources, and we want to understand how to deploy them appropriately. This trial looks at medical therapy management pharmacists to be able to hopefully intervene on heart failure patients. So they're predicting risk. So if we think about it this way, we're predicting risk, but we also want to understand the benefit. So there, if you see here, there's predicted risk and predicted benefit. There's a high, a high, and a high-low. So if you think about it this way, if we predict risk, here's going to be the average one-year mortality rate based on that baseline risk. Here we would, parse out the low-risk patients. Here we would have high-risk patients with a high benefit. So if you also notice in the top corner, there's predicted benefit by the percent mortality risk reduction. So the first is your low risk in the bottom left corner. Then we have the high risk and the high benefit. And why this is important is because there's also going to be a high risk, low benefit group, where if we look at prediction alone, you could prioritize resources based on that prediction that you actually can't do anything about. So the benefit is also something we need to understand when we're looking at these different things, to understand the risk plus the benefit. So we would not presumably intervene on the high risk, low benefit, but would intervene on the high risk, high benefit. And then another example that we've implemented at the point of care is radiology workflow optimization. So the goal, again, is resources. We have resources where radiologists can only read so many images per day, and they have a very long work list. In an outpatient setting, there could be something very important in that work list that gets put to the bottom in maybe 3 or 4 days until it gets read. The goal of this study is to read the most acute and actionable studies first. So they developed a predictive algorithm to look at CTs and MRs, CTs specifically, as they're coming off the scanner, look for anomalies, and then put those at the top or towards the top of the work list for the radiologist. So this is a project that we've been running for about 2 years. There's been some great success stories. We have intervened where a patient came in with a headache, got a CT, found a bleed, and then we, before they left the radiologist's office, they were escorted to the ED, and then really reduced the amount of time that bleed would occur and happen. So there are caveats to this though, right? So with everything, you're going to have a false positive rate. So again, we're not harming anyone potentially, but we are going to be prioritizing false positives that would eventually get read anyway, but bump to the top of the queue. And then lastly, the care gaps portion. So mostly this is focused on automating standards of care and really understanding nurses and how they can manage care at a population level. So it's not it's again at the population level, not focused on individual interactions. So this is a tool that's used where care managers and nurses prompt patients to satisfy standards of care before visits with providers. So within a normal care process, there's going to be a lot of things that patients are asked to do, and sometimes they follow through, sometimes not. Sometimes they forget. Sometimes they don't even know that they were supposed to do it. So this is a way that we proactively reach out to patients and ensure that they're doing things before they get into the doctor's office, or something they need to have a conversation with the doctor about at the time of care. So things like diabetic foot exams, making sure that the labs you were supposed to get, you actually got, things like that. So lastly, I just again wanted to touch on lessons that we've learned throughout this journey. One of our key driving visions and core visions, principles from the beginning was organizational commitment. We do still have a strong organizational commitment, and I think that needs to maintain. I think it's very key, very important. We have to, from our CEO to our CDO to our CDIO, all the way down to clinical leaders, researchers, we all have to be on the same page about what we're doing. Let the infrastructure fit the needs of the business, not the other way around. So there's a lot of times that we get caught looking at the newest software out there. We think it's going to be really beneficial, but at the end of the day, it doesn't fit the needs of what we're trying to do. And if we start making those decisions based on the next cool thing, we lose sight of what's actually driving us forward. To a point, we did that with moving completely out of a relational system into Hadoop. I think we're probably going to reduce the amount that we deal with unstructured and do a hybrid approach. Data infrastructure is not data analysis. So due to resource constraints, we often have people that wear both hats, and I think that's very important that people do things differently based on their skills, even though it may end up being more time and effort devoted to the differences. I think they do need to be separated. Investing in a standard data model and standard architecture and support, I think this is really important too, because if you're maintaining multiple data models or you're maintaining different storage architecture, different hardware, it makes it really hard for operational folks to help support those types of things. So standardizing storage infrastructure, hardware, software, the data model itself will reduce the amount of time of support that's needed to be able to really drive a really good data infrastructure forward. Subject matter experts, data wranglers, are extremely critical to big data and data science. Our personal opinion is, despite what you read in the paper, more data is not necessarily a good thing. Good data is a good thing. So really understanding what those clinical workflows are, understanding that subject matter expertise, that those are the things that have built better models for us and resulted in actionable care instead of just risk prediction. So again, looking at the prediction versus benefit is really where we rely on these subject matter experts to create a holistic study team instead of just a big data team. And data science is a really useful tool when there is a need. So don't predict things just for the sake of predicting things. Make sure that it can actually be an intervention and understand that what you're doing can actually be changed. So one of the models that we looked at the other day, if you have specific things like patient sex was one of the top predictors. But when you're implementing this, there's not really much that a doctor can do to change that outcome. So finding outcomes that are actionable is important. It's the same thing we think about in the genomic space of, I can't report back something I can't help you with. That's what we should be doing on this in the data science world as well. And then lastly, identify incomplete, inconsistent, and inaccurate data and share that knowledge. So don't ignore it and don't pretend it doesn't exist. Like I said, with big data, we need to be able to identify these areas and then actually discuss them openly and build a platform that people can understand and embrace that across different research organizations. If you're collaborating with folks and you put your data in, and this person has radiology visits and this person doesn't, you do a study and all of a sudden you have different rates, people need to understand all these different things. And I think we need to build a framework better than what we have, and we need to recognize that we're not as great as we think we are and can actually explain what these things mean to other people looking at your data, not just within your own walls. And with that said, I probably could have put more acknowledgements here, but I just tried to keep it to one slide. So again, our MyCode Community Health Initiative, our program leaders, our cardiac imaging and technology team, and then MyCore have done everything on this slide. So with that, I'll open up to questions.
Joe, maybe I'll start. So thanks very much. That was really, really great. And I can certainly tell you, I would agree with all of your conclusions. I think they certainly fit with personal experience and what a lot of us experience here in the many years we've been doing this too. Can you alluded to something there toward the end that I'd just love to hear you expand a little bit on, the data lake versus the more sort of organized relational model. Can you just unpack that a little bit more? What are your thoughts there?
Yeah, so we made a decision to try, years ago to just go straight Hadoop. So this was probably 3 to 4 years ago. What it's great at is unstructured data, which we have a lot of in healthcare. What it's not so great at is most of the reports that are generated and run from day to day, which are based on structured data within Epic, within our other 99 data sources. So the route that we are currently discussing and thinking about is, what about a hybrid environment? So we've seen this successfully used in other spaces. So we probably will reduce the amount of our cluster and then add a structured data environment based on, again, the necessity of a data model, right? So that's the key thing is, if you don't have a data model, your data lake's great. If you do have a data model, it doesn't run well in that data lake. Yes.
So I also really, David Hagstrom in the Health Services Research Program. So I really liked the lessons learned that you shared. The point related to subject matter experts, which you mentioned a few times, and data wranglers. I was interested, could you expand a little bit about how you organize that part of your workforce? Like, is it disease specific? Is it ad hoc based upon projects? Or how do you bring those, how do you address that operationally?
Yeah, so it's a great question. It's a little bit of both. So we do have data subject matter experts within data domains. So that is one thing. Then we also have a much larger study team that includes clinician or nurses or practitioners. So those are always involved as well, and potentially IT from those sides to be able to understand the workflow. We do maintain, as requests come in, to try to get those domain experts, but we also want our programmer analysts to understand the full workflow. So we generally will include non-experts in parts of the project so they can get an exposure to them as well. Because we don't want people, we want people that are really strong in areas, but we don't want people that if someone leaves, then we have no idea what happened. So we do try to cross-train as well, which has been pretty helpful. And plus, just from an analyst perspective, I think the general satisfaction if you're working on multiple areas versus just one, can be helpful too.
So regarding that same question, kind of, if you detect defects in the data, and you said, you know, keep the knowledge, don't be shy about communicating that, and et cetera. What are the mechanisms? So you have the relational, the structured data, more controlled. So you will certainly fix that in the source. But how far can you go down to the origin of the data? I mean, since you're more connected to your healthcare system, for instance, if you find defects that truly could affect clinical care, for instance, would you go as far as sending those?
Yes. Yeah. So
can you talk about that?
Yeah,
please?
absolutely. Yeah. So we definitely do this. So there is a data quality group that is under our data governance office that focuses exactly on mobilizing efforts in HIT and HIM. So an easy example, which is amazing that there's not a bigger group looking at this, but we would run into studies where we would have what we would call zombies and Doc Browns. So these are patients that utilize care post-death date, so the zombies, and then patients that utilize care before their birth date. So these are the Doc Browns. So these are ones that you would think should be easy to identify to HIM, but when there's not a holistic, centralized approach to doing that reporting, it doesn't exist. So we report that back to the data quality team, and then they would then mobilize the HIM team to review those specific charts. Workflows are similar. If there's something where we get divergent concepts recorded differently, which can be a problem, those would go back to our nurse and provider information department within our EHR department.
Can I ask, what about, you know, one of the things to variation is also standardizing data collection at the point of care within groups. We've had some experience with that, but I don't know of anybody doing that holistically. Is that something that same group would look at to say modify templates, et cetera?
Yes, and that's actually how that group started. We don't have nearly enough to do it at scale, and that's something we want to do better. And so, yeah, I wouldn't claim that we're doing it better than others, but it is something we are actively working on, and that's just an economy of scale issue. Yeah.
Do you have one set of MRNs for all hospitals? And if not, how do you link to patients?
Mostly, there are differences. So we do have a master data management department that builds a master patient index, but that's not 100%. And there are ancillary systems that I talked about. So almost, you know, when you think of your big three, our claims, our billing, and our EHR, those would have great MPIs. These one-way interfaces, it's the MRN as the time of the message that went over. So those will not go back and update the source, that originating system. So we develop methods similar to what our MPI group does to be able to do that mapping.
Can I ask another question? You have a whole bunch of self-service tools. How often do they actually get used, by whom, and for what?
Yes, quite often. So I would say daily for almost all of them. And they're specific to the different types of researchers based on their comfort level for programming. Some are operational based. So when I talked about like web intelligence, Tableau, those are visual tools that get used for operational decision making. And then everything else is used by epidemiology, biostatistics, data science, image science, et cetera.
You talked about so much stuff.
I apologize.
There's a lot of stuff to get more into detail, but I wanted to ask about your digital phenotyping.
Yeah.
What, just I guess as to borrow Peter's words, to unpack it a little bit, what What do you do about sort of expiration of a digital phenotype as there's drift in the data? How do you validate it? That's an expensive process. Can you just talk a little bit about your collection of data of digital phenotypes?
Yeah, so this is definitely a problem, and definitely something we are still working on methods for. But in general, the way that it would work is we have infrastructure built that we can either, say we want a quality measure or something from PKB, we'll transform it into our standard process for running the code, maintain that library of code, do the validation, record the output. Maintenance of this, I think, is what you're getting at, which is incredibly difficult. The best that we've been able to do is we will rerun that phenotype every month, and then look at prevalence rates and look for a substantial difference based on some algorithms that we've developed. It's not foolproof by any means, but it seemed to be pretty good. The other thing is anytime that we can identify a change in a term, so anything that comes through in our audit tables, if that code is used in any of the algorithms, because again, they're in a standard library, that triggers an event to go say, hey, this code's used, you might want to go look at it. Similarly, with like a clarity data model change. So anytime there's an ETL change, we have a library of every table and column that gets hit. If there is deprecated data or new data added, it triggers an event to go look, which those things happen less frequently, sorry.
Thank you so much.
Great, thank you.